This video is about making a helicopter rotor from a tongue depressor, as well as instructions for making a pull string launcher for sending it high into the sky. But first, an introduction. When I was a kid, I used to love these cheap plastic helicopter toys. So when I saw one of these at my dentist's office, presumably for a younger clientele, I swallowed my pride and I begged for one. And then there's this simple helicopter that you spin in your hands. Both of these toys have flat rotors, yet I know that real helicopters and airplanes have shapes called airfoils that are more efficient. Could we apply some basic theory and make super helicopters that would soar above treetops? To learn more about helicopters, I visited Mr. Scott Welsh, an aviation instructor at the Pennsylvania College of Technology. I wanted to get some video of helicopter parts, especially the airfoils on the rotors. So while Mr. Welsh inspected the helicopter, I looked for airfoils. I discovered that even the small tail rotor has a symmetrical airfoil. The main rotor has an airfoil too, and by the way, the rotor goes in this direction. The rounded front is called the leading edge, and the sharp back is called the trailing edge. Scott showed me how the pilot can vary the angle of the rotor blade, which is a subject we'll come back to when we make our helicopter blade. I couldn't help noticing that as he inspected the helicopter, he didn't leave anything to chance. The helicopter has a fuel gauge, but he wanted to see the fuel level directly for himself. I was ready to pack up my camera and go home, when Scott asked me if I wanted to take a ride. Let's go. Notice that he's putting on a headset. It's too noisy to speak the normal way.
We're in the air. We're following the river to Jersey Shore, the town where I teach. There's the bridge into town. There's the middle school where I teach. There's a nearby elementary school, and there's the high school. airport, where Scott showed me how controls on a helicopter work. In the back helps control turning. Nudging the left pedal then makes it spin left. Pushing the control stick forward makes the helicopter go forward, and pulling back makes us go backward. And as you might have guessed, tilting the stick sideways makes the whole helicopter fly sideways. Way back, there's time to enjoy flying near the puffy clouds and see what the world looks like to a bird that soars through the air.
Watch your head.
Yep. Thank you so much, Mr. Scott Welsh. As we build our helicopter, we'll refer back to this helicopter at certain steps. This is a challenging project, and your first helicopter will take over an hour to build, but it's worth every bit of work you put into it. You'll learn things about the science and technology of flying, and right away, you'll apply them to building your own helicopter. And when you're done, you'll be able to launch this creation you've made with your own hands far into the sky. You'll start by marking and drilling a tongue depressor. Then you'll make a forming tool from cardboard and hot glue that'll help you create a perfect airfoil. You'll form the actual airfoils from cardboard too. You'll learn something about momentum and see why we add weight to the tips of the helicopter. After gluing everything together, we'll add an angle to the airfoils by using heat to twist the wooden tongue depressor. And then it's time to fly. These video instructions are divided into steps. Some of the steps are long, some of them are short. I ask that you watch a complete step before doing anything on your project, so you don't miss a detail that could affect your project. How will you know when a step is over? You'll see a super fast motion review of the step.
And you will hear me talking like this.
And of course, When the instructions are not clear, simply click on the playhead and drag it back a little bit to see that part again until it makes sense. And drag it back a little bit to see that part again until it makes sense. Go on to the instructions for making the helicopter. There are also instructions for making an inexpensive launcher for the helicopters. The core of your helicopter rotor is a wooden tongue depressor. Put the tongue depressor on top of this pattern to make the important marks. The ends of the pattern should be an equal distance from the ends of the tongue depressor. Notice that in this example, the tongue depressor needs to be pushed a little bit this way to make them even. Mark the middle of the tongue depressor and the two places farther toward the ends where the airfoils will start to be glued on. Try to make a cross right in the middle. That's where you're going to drill a hole. Here's a thought. Everybody's second and third helicopter, they're better than their first one. And it's just as easy to stack up 3 tongue depressors and drill them all at once. Mark the top one. Then line 3 up and tape them together. If you run a line down the sides, you'll quickly mark all the tongue depressors.
With the pattern, measure 1 or more tongue depressors.
You'll be drilling a 1/8 inch hole, which is about 3 millimeters. You can use a hand drill or a drill press. Some of the smaller drills have keyless chucks, which you twist to tighten. Make sure that you don't drill into the table below. And never put any sideways pressure on a thin drill bit like this, or it will snap off. Here's a drill press with a keyed chuck. It's nice to have, but you don't need a drill this fancy to do the job. When you take off the tape, you can fill in the lines between the side marks. If you're working in a group, it's a good idea to get your initials on your project.
Drill a hole in the middle.
Remember the shape on the end of the helicopter blade? It's called an airfoil, and it greatly increases the lift, which is good, and greatly decreases drag. Drag is bad, and so it increases the efficiency of the helicopter. This is a NACA 0012 airfoil. NACA, in case you're wondering, was the forerunner of NASA. To make the helicopter fly high, you'll make cardboard airfoils for the helicopter. But first, you'll make a 0012 shaped hole in a piece of cardboard as a tool to help form the airfoils. So let's get started by cutting just outside the line of the NACA 0012 airfoil. At this point, you have to decide what you're going to make your airfoils and your airfoil forming tool out of. And the choices are either thin cereal box cardboard, which is like thin poster board, or milk cartons. Milk carton cardboard is a little bit stronger and it's waterproof, so if your helicopter lands in the wet grass, it doesn't fall apart. On the other hand, cereal box cardboard is lighter weight, easier to cut, and easier to form. Whichever kind of cardboard you use, the procedure is just about the same, so we'll switch back and forth between the two. I suggest that you make your first helicopter out of cereal box cardboard because it's easier, and then after your first helicopter, decide then if you want to go to something else. Let's continue making the airfoil forming tool. Cut out a piece of cardboard, either milk carton or cereal box, at least 3 inches square. It could be bigger, but it shouldn't be any smaller than 3 inches square. 3 inches is about 7.5 centimeters. The airfoil pattern is going to be taped in the middle. Cut a piece of tape. You have to be able to see the pattern through the tape. And you could use masking tape, but obviously clear tape is better for this. Press down the tape pretty firmly so the pattern doesn't slide around when you cut out that shape in the next step. Whenever you tape onto the cereal box cardboard, it's best to tape onto the print side, not to the gray non-print side, because if you have to take the tape off on the gray side, it'll take a lot of cardboard with it. You need to make a perfect airfoil-shaped hole in the middle of the cardboard. So you cut through the cardboard to the pattern and start cutting exactly on the edge of the pattern. The idea is to cut exactly in the middle of the line, even around the curves. I know that we all learned to use scissors in kindergarten, but cutting this accurately is tough. Experiment. You might prefer to cut 1/2 on one side and the other half on the other side. Notice that the cut goes right through the middle of the black line. You could even cut the cardboard and pattern in half. And don't be afraid to bend the cardboard if it gets the cardboard out of the way of the scissors. You can peel off the tape holding the pattern together. And it's easy to tape the halves back together. Obviously, line up the sides. Whether you're making your airfoil forming tool out of a milk carton or a cereal box, make several and choose the best one.
Tape an airfoil pattern onto cardboard and cut out an airfoil-shaped hole. Make at least 2 and choose the best one.
Plug in a hot glue gun to get it warmed up. If you have not already, tape where you cut through the cardboard to the airfoil. You'll be gluing where the cardboard was cut, but that's not all. You'll also be squeezing a bead of glue all around the edge of the airfoil. The idea is not to just glue, but to strengthen the airfoil forming tool all around. Let it harden first, then put the hot glue around both sides. Glue close to the edge for strength. Of course, you don't want a gob of glue to go into the shape, but if it does, hot glue is sticky, so just sort of pull it back with the tip of the hot glue gun. When the airfoil forming tool has glue around the edges on both sides, it's ready.
Glue the forming tool.
Now it's time to make the airfoil-shaped rotor tips that will give this helicopter the efficiency to fly really high. Rough cut out, in other words, cut a little outside the lines, a rotor tip pattern. Make a sticky tape donut by sticking a piece of tape back onto itself with the sticky side out. Push it onto the non-print side, on a side that does not have the dashed line running into it. Put another tape donut opposite the first. What I mean is, the tape donuts go on the other side, here and here, not here and here, because there will be some folding on the dashed line. If you're using cereal box cardboard, make sure that you tape to the print side, because if you tape to the gray side, when you peel off the pattern in the tape, lots of cardboard fibers are likely to come off with it. If you use a milk carton, it doesn't really matter which side you tape the pattern to, although the side that you tape the pattern to will be the side that shows. And because of the way that cardboard is manufactured from fibers, it can be easier to bend it one way than another. So if you can observe on the pattern where it says top and bottom or sides and tape it on that way, you might have a little easier time. With the pattern taped on, cut through the pattern in the cardboard exactly on the outside solid lines. You'll need 2 of these, one for each end of the rotor.
Cut out the airfoils.
I'm using paper here, but have you ever seen somebody curl a ribbon with a pair of scissors? The fibers going over a sharp edge are permanently changed. We'll do a similar thing with the cardboard to get nice smooth curves for the airfoil. This table edge is okay. You can see how the side of the cardboard that was run around it curves, but the table edge is quite rounded and it's hard to get good results. If you can find a table with a sharper edge, it'll be easier. It's sort of hard to describe how you do it. It's like holding back with one hand and pulling down really hard with the other hand. Notice that the cardboard is oriented so that the dashed line is parallel to the table. If you fold it like this, can you see where it's going? If you're using milk carton cardboard, scuff up the side opposite where the pattern is taped on. This will be the inside of the airfoil where several things will glue on. Milk cartons have a waterproof plastic lining. It's very smooth, so glue has trouble sticking to it. But if you scuff it up, the glue has something to grab onto. Peel off the pattern and the tape. You can save it for later if you want to. Start folding the cardboard into the airfoil shape, but be careful. You bend more in the middle, where the dashed line was, than the rest of the cardboard. But it's not a sharp bend. The leading edge here is slightly curved. The sharp part of the airfoil, which is the trailing edge, is made by the two edges of cardboard coming together.
Curve the airfoils.
Cut off a piece of tape a little bit longer than the airfoil. I really like red or yellow electrical tape because it shows up even if your helicopter lands in the weeds. Bend the cardboard back on itself. Make sure the edges line up and the corners line up. Then lay the tape lengthwise so half of it is sticking out over the edge. I use the tabletop to evenly push the tape on over and stick it to the other side, but use whatever method works for you. Cut off the extra tape sticking out on the ends. It's time to start using the forming tool that you made earlier. Always push through a taped corner first, or else the tape is likely to be snagged. But if the angle is too steep, like this, you'll have trouble getting the rest of the airfoil through. Now, in a perfect world, this is all it would take to make a perfect airfoil. But life is full of twists and turns, and look what's happening with the airfoil. Instead of expanding enough to take the right shape, it's staying a little bit too narrow and squished. Can you see the daylight showing around the edges? I tried bending out the cardboard, but what really works is clay pushing from the inside, and that'll be detailed in the next step.
Tape the airfoils. Put an end in the former.
In this section, we'll measure out weight, or actually mass, to add to the helicopter tips. At first, that doesn't seem to make any sense. After all, when we make rubber band-powered model airplanes, we use lightweight materials like balsa wood and tissue paper. But this has its own power supply. But consider this situation. My daughter is throwing a balloon with air. It doesn't get very far. Now she has another balloon, same size, but now it's filled with water, equal volume, but much more mass, so it's denser, and it pushes through air resistance with no problem. So did adding mass help us go farther? Yes. Let's take it one step further. Here's a turntable bearing for easy turning. Notice that when I set it spinning, it doesn't go very long. Not only am I going to add mass, but I'm going to add this arm so that I can control where I put the mass. When I spin the arm, it spins longer because some of its weight or mass is farther away from the center than before. I'm going to add some rocks to the middle now. Disappointing. So let's move the rocks to the outside and try it again. Looks like that's gonna go for a while. While we're waiting, what's the difference between weight and mass? Let's push this off to the corner for a minute. Imagine you were in outer space, far away from planets or stars, and far from their gravitational pull. That hammer would float in space and have essentially no weight. But if you swung that hammer and hit something, you would still smack it good. The hammer might be weightless in outer space, but it still has all its mass. For most of history, in fact until Sir Isaac Newton, even the smartest people did not understand weight versus mass. So it will take a little time to sink in. Back to the turntable, it finally stopped. It wasn't enough just to add weight. Where we put the weight mattered. So if we put the mass in the middle, it would just weigh down the helicopter. But if we put the mass on the ends of the helicopter, it'll keep that helicopter turning a long time. The weights out here are traveling faster, so they have more momentum. This is sometimes called the flywheel effect. By the way, do you remember that plastic helicopter toy? It has a lousy airfoil, but that ring isn't just for safety. That mass on the outside gives it lots of momentum and keeps the helicopter turning. That's why it flies so well. On your helicopter, when you combine momentum with airfoil efficiency, you won't be able to fly it indoors, even with the high ceiling of a gym. We've already used hot glue, and that might seem like a logical thing to use for the weight. But we're going to use non-hardening clay. Here's why. I have identical bottle caps. Each is about 1.5 grams. I filled up one bottle cap with hot glue. And I filled another bottle cap with an equal volume of clay. But even though the volume was the same, the clay weighed almost twice as much as the glue. So clay is a better weight because it's more dense than glue. Modeling clay comes in all different colors. Just make sure that you have the non-hardening kind. We're going to put 5 grams of clay in each end of the helicopter. There are a couple of ways to measure out 5 grams of clay. Measuring clay with a triple beam balance is fun. Start by putting all the weights to the left. The pointer should go to 0. Then move the 1 gram weight that's in the front to 5. The pointer will go down until you get 5 grams of clay on the tray. Keep adding chunks of clay until the tray goes down. Usually I overshoot and I have to pick up and break up a piece of clay until I get it just right. If you cannot get a hold of a triple beam balance, you can still measure with amazing accuracy the old-fashioned way. It happens that a United States nickel weighs exactly 5 grams. If you take a ruler or any stick like that and hang it from the middle with a string, you can make a basic balance scale. Cut a piece of paper fold it over to make a square and cut it there. Tape off one side so you have a little pouch. Make 2 of these pouches and tape one to each end of the stick. Add a nickel to each pouch and get them to balance. You can achieve balance by unsticking the pouches and moving them back or forth. Moving a pouch toward the center makes that end go up. Moving a pouch toward the end makes the end go down. Take out one of the nickels and replace it with pieces of clay until you get balance again. That's 5 grams. You need 2 lumps of clay, each lump 5 grams.
Measure 5 grams of clay using a triple beam balance or an old-fashioned balance scale.
Plug in a hot glue gun and get it warmed up and ready. Find this rectangle pattern and flatten out the 5-gram lumps of clay to approximately fit it. Especially if you're working in a cool location, at any time you can warm up the clay on top of a hot glue gun and it'll be easier to work. Fit the airfoil into the forming tool and sort of leave it at one end. Put the clay rectangle into the other end. Notice how the clay is recessed. Recessed means pushed in about 1/8 of an inch or about 3 millimeters. Now draw the forming tool to the end with the clay. Do you remember how there can be a problem with the airfoil being too thin? Well, the clay tends to push back from the inside, so that shouldn't be a problem anymore. And remember how the clay is pushed in a little bit? You're going to cap off that space with hot glue. It's hard to get the glue in at the taped trailing edge because it's so thin. So you have to go at it a little bit more aggressively. Notice that I pushed the tip of the hot glue gun in a little bit to make sure I got the glue in. Also push some glue into the leading edge. Then just sort of fill in the remaining space with hot glue. When it's filled up, set the glue end down on a piece of scrap paper and let it rest for about a minute for the glue to harden. Then peel off the paper and sort of use your fingernails to clean up the edge. Both airfoils need the clay and the glue.
Put the clay in the tip and glue it in.
Plug in a hot glue gun and get it warmed up and ready. Do you remember marking out the tongue depressor? You'll apply hot glue from the mark to the end on both sides of the tongue depressor and glue on the rotor tips. But there's a problem. The tongue depressor is flat. The cardboard airfoil is not. You need lots of hot glue to fill in between. But most people don't use enough the first time they make a helicopter. So how much is enough? The answer is 1.5 inches of glue stick, half of that on each side of the tongue depressor. For your first helicopter, I think it's a good idea to measure 1.5 inches or 4 centimeters of the glue stick that's coming in. It's pretty easy to do if you have more than 1.5 inches of glue stick sticking out. But what do you do here? You can get the next glue stick and line it up end to end, measure and mark it. Then, after the first glue stick is gone, you can add the next one and use it up until that mark. A possible problem with that idea is sometimes when you first put a glue stick in, it doesn't feed right until you push it in with your other hand, either because it slips on the glue stick or the trigger doesn't spring back enough. That can be hard to do with your other hand holding the tongue depressor full of hot glue. You might get somebody to help you, or you might try this. It's possible to melt the ends of hot glue sticks together. I'm not saying it's easy, but it is kind of fun. Preheating the ends might make it easier. They'll have to be lined up perfectly, or they won't feed through. And for the same reason, scrape off any bumps. Before you start gluing, make sure that the forming tool is at the clay end of the airfoil. Start adding glue fairly evenly from the mark to the end. About half goes on one side and about half on the other side of the tongue depressor. You have to work fairly quickly to get all that glue on before it has a chance to harden. Then put the tongue depressor and glue inside the airfoil. Stop when the airfoil reaches the mark. The tongue depressor should be in the middle of the airfoil or slightly toward the rounded leading edge, as it is here. Slide the forming tool toward that end. Leave it there for about a minute while the glue sets. Gluing the other airfoil on the other end of the helicopter is similar, with one very important addition. The taped airfoil edge must be on the opposite side of the tongue depressor. So if the taped edge of the first airfoil is on this side, the taped edge of the second airfoil should be on this side.
Glue the airfoils on.
I got it. All right, ready? Yep.
If I spin this turntable hard enough, the rocks don't stay there.
All right, here you go.
They fly off. Perhaps you've seen the spin cycle of a washing machine, or ridden on a carnival ride. I think it's called the gravitron, where you spin and they actually tip you up on your side and you're held onto the gravitron by centrifugal force. Actually, the correct terminology is centripetal force, but I'm not going to get into that here. Suffice it to say that when something spins fast enough, objects are apparently thrown outward from the center. Nobody believes me until it happens to them, but the force is so great that unless you take measures to keep it in, the clay weights at the tips of your helicopter will be thrown out. You might say, well, we've already glued them in, haven't we? If a teenager or an adult pulls the string of the launcher hard, glue alone will not be enough to keep the clay in. I present to you Exhibit A. I thought that glue plus one piece of tape to hold the glue in would be enough. It wasn't. You can see some remnants of the pink clay here, here, and here, but most of it's gone. It only takes a pinhole to lose it. When I try to balance it, it's completely unbalanced with all the clay gone. It won't work even kinda sorta. Here's what seems to work. I cut off pieces of electrical tape about the length of an airfoil. I tape about half to the middle of one side. As you go around the end, pull it a little bit so it's under some tension as you tape it to the other side. Cut another piece of tape and put it right on the edge of the trailing edge. Then the last piece of tape goes on the front or that curved leading edge. The idea here is to completely cover the end, but not have extra tape at the leading or trailing edge flapping in the breeze. Extra tape would interfere with the airflow.
Tape the clay in.
We haven't really covered the control that makes the helicopter go up and down. Actually, it's two controls in one. The throttle controls the engine speed. This instrument, a tachometer, shows the engine speed. When he's ready to lift off, Mr. Welsh said the arrow should be between here and here. So the engine and rotor speed are controlled by a twist throttle, similar to the twist throttle found on many motorcycles. On your helicopter, the rotor speed is determined by how fast you pull the string. There's another factor that affects lift. You can feel it in a car traveling fast on a highway. Even though a hand makes a pretty inefficient airfoil, if you tilt your hand up, it tends to go up. If you tilt it down, it goes down with much more than the force of gravity. If you do too much tilt, it just does what's called a stall. That just drags your hand backward with little or no lift. On a helicopter that carries people, the rotors are variable pitch. They can have lots of angle for lots of lift, or on the ground, they can have no angle for no lift. This angle is called the angle of attack. That's controlled by the same levers that have the throttles at the end. Notice that there's a duplicate set of every control so that you can fly from either seat. On your helicopter, the angle of attack is made by permanently twisting the tongue depressor. We used to make the twist by immersing the tongue depressors in boiling water, then twisting them into a bending jig. We had to let them dry for a day before we could use them. Now we have a better way. We use the heat from a candle. It only takes a minute to make the twist, and you can go back and change it. But here's the rub. You've got to get it twisted the right way. Normally, you'll pull the string and the helicopter will lift very quickly. But here, I intentionally twisted it the wrong way. The coat wasn't for cold. It was a hot day. The coat was for protection. I was lucky that the helicopter hit the launcher and flew off to the side, but it could have just as easily flown down and cut up my hands, or the scalp of my head. If you twist your helicopter the wrong way, it will fly down instead of up, and you are what's underneath the helicopter. So here's the strategy I suggest for getting the twist right. As one end of the copter faces you, the left is down and the right is up. It doesn't even matter if the helicopter is upside down. On the end facing you, if the left side is down and the right side is up, you'll get it right. Never touch the flame to the wood and keep the wood moving constantly. If there's too much of a breeze, you might have to set up barriers to form a windbreak for the candle. After a minute or so of twisting and heating, or until the wood is hot, take it off the heat, but keep twisting it for half a minute or so while it cools.
Twist the tongue depressor.
When you launch your helicopter, it will be like Mr. Welsh's. It will go this way with the curved leading edge in front and the sharp trailing edge behind. You might want to mark this as the top right now because it's easy to forget. You don't have to do this, but if you want a little bit more lift, you can bend the inside corners of the airfoils down. Do it only in the inside corners, because this part of the airfoil travels slower than the tips. Bending an airfoil like this is called cambering. Put the helicopter on the launcher like this. Wind it up so that the end is on the left. So when you pull the string, it'll go this way. When you've accelerated the helicopter to its full speed by pulling the string, it'll then ramp off like this and start flying on its own.
Fly your helicopter!